Okay, for today, again, we're in our Unit 1 notes packet and we're starting on page 4. We're going to start off with some stuff that I know you guys have seen before to kind of ease us into the stuff that might be a little new or things that we're going to take a little bit different perspective on. So on page 4 at the top, we're looking at plotting some points on a coordinate plane. And I know that you guys know how to do this. You worked on this in geometry last year. This is something you've seen before all the way back into probably middle school. But just a quick review, sort of as we are going to talk about and use coordinate planes this year. Remember, we have names for different sections of the coordinate plane. So over here, we call this quadrant 1, this section of my coordinate plane where all the values are positive. And then we move counterclockwise. So over here is quadrant 2, down here is quadrant 3, and then right below quadrant 1 is quadrant 4. Okay, so I've got these different areas of my coordinate plane and we have names to be able to talk about them. Also remember that our axes have names to them. My horizontal axis is my x-axis. My vertical axis is my y-axis. So in quadrant 1, both our x and y values are positive. A lot of the like real life or in context problems that we'll look at are going to live largely in quadrant 1 because the things we're talking about we want to be positive values. Quadrant 2, I have negative x values but positive y. Quadrant 3, everything's negative. And then in quadrant 4, positive x but negative y. Okay, so this is all stuff that we should be familiar with from our earlier math classes. And we're going to start by looking at plotting some points. So remember, anytime I look at a point, it's called an ordered pair because it's an arrangement of an x and a y value. Okay, it's a description, okay, based on x and y. Remember, it's in alphabetical order. If that helps you, if you get kind of turned around, it's always x, comma, y. Okay, it's in alphabetical order. And so what we're seeing here with each of our ordered pairs is how far to go on the x-axis or what value to go to on the x-axis and then what value to go to on the y-axis. Okay, so for A, 3, 7 means I go to 3 on the x and then to 7 on the y. And that's my point A. For point B, negative 4, 1 means I'm going to go to when x is negative 4 and y is 1. So we're there in the second quadrant for our point B. For point C, negative 8, negative 6 will be down here in quadrant 3. So I go to where x is negative 8 and then down to where y is negative 6. There's point C. Point D, I'm going to where x is 10 and then down to negative 2 for y. So we're over here in quadrant 4 for point D. And then E and F are both going to be on an axis. They won't be in a quadrant. They'll be on an axis. So for E, our x value is 0. So we're not moving left or right any. We're just going up to 7. So we're on the y-axis there for point E. For point F, we're going to be on the x-axis. We're going to where x is negative 5, and then we don't move up or down any. We stay on the axis for point F. Questions for me so far? This should be familiar, yeah? You guys have done this before, okay? The last couple of things that we're going to refresh are graphing lines. Now, later on this semester, we're going to see a whole unit where we talk about linear functions and lines. We're going to talk about different formats that lines can be in and the different information that we get from those different formats. You guys, up to this point, should be familiar with point-slope form, or not point-slope, slope-intercept form, which is what we see here, slope-intercept form. Remember, it's called slope-intercept form because it tells me the slope, that's my coefficient for x, and my y-intercept, that's my value at the end, that constant term at the end. Okay. Remember that slope, we can think of as rise over run. So when slope is given as a fraction, that top part refers to how far I go up or down, and the bottom number refers to how far I move forward. So as I'm looking at graphing some lines, remember we want to start with the point that we know, which in this case would be the y-intercept. So I have a y-intercept of negative 9. So I'm going to start by plotting my y-intercept on the y-axis down at -9. And then my slope is 1/2, so that tells me I'm going to go up 1, rise 1, and then forward 2. So from my y-intercept, up 1, forward 2, up 1, forward 2, up 1, forward 2, up 1, forward 2, and I'm just going to go until I run out of space here. And then since I have the equation of this line, I know that I'm going to connect this and throw my arrows on the end. And there's line L. For line M, same idea. I have a different y-intercept this time. This time my y-intercept is 6. I'm going to start up here at 6 on the y-axis. And then my slope is negative. So that's telling me that I'm moving down instead of up. So positive versus negative always refers to the rise. Am I going up or down? Since my slope here is negative, that means we're going to go down. So down 2, forward 3. So down 2, forward 1, 2, 3. Down 2, forward 1, 2, 3. Down 2, forward 1, 2, 3. And again, until I run out of space to be able to plot that next point. And since I know that this is the equation of a line, I'm going to go ahead and connect these and throw my arrows on the end. Later today and into tomorrow, we're going to talk about the difference between having the function for a line that describes something on the graph versus graphing information or data that I've collected, and some differences in how we create those graphs. So from our review, that's kind of where we're going to take this. So if I have a context to what I'm graphing, how does that maybe change the way that I create that graph? Questions for me so far? Okay. We are going to hit the pause button on the bottom of page 4. We will come back to that probably tomorrow. If you would for me, please turn to page 5. Who has ever had to create some sort of graph for a science class? Like you had something you had to plot, you maybe did an experiment. Yeah, and you had information that you needed to create a visual representation for. Did your science teacher, like mine, really hound you about the importance of making sure you label your axes? Make sure your graph has a title. That was my science teacher's big deal. Make sure your graph has a title so I know what it is. Okay. And one of the things that you had to decide when you were labeling your axes in particular, your x-axis and your y-axis, was how do I know what label to put where? How do I decide which information goes along my x-axis and which information goes along my y-axis? Remember, x is horizontal, y is vertical. Okay, so what we hopefully should have learned in our science class, but what we'll review today, is that x is what we use to represent our independent variable. Okay, independent is the thing that I am in charge of or the thing that I control. Okay, so if I am looking at the rate at which a pot of boiling water cools, the thing that I can control is how often I check the temperature of the water, right? So that time when I check the temperature of the water would be my independent variable. That's the thing that I'm controlling. I'm in charge of when those temperature checks happen. Our dependent variable, also called our response at sometimes, is what goes on our y-axis. So in the example I just gave, the dependent variable, the thing I would label on the y-axis, would be the temperature of that pot of water. What's happening to it? Is it getting warmer? Is it getting colder? What's going on there? That's the thing that I'm measuring. That's the thing that I'm not in control of. I'm not in control. Once I turn the heat off my stove, I'm not in control of how fast or slowly the water changes temperature. That's what I'm trying to figure out, okay? So the independent, again, is the thing that I am in charge of, the thing that I am choosing or controlling. The dependent is the thing that I am measuring, the thing I am gathering the information on, okay? What's happening as a result of the choices that I've made. So what we're gonna take a look at on page 5 is identifying independent versus dependent variable. What we're gonna see a lot of in algebra is not like experiments and data collection. We will do that from time to time, but what we're gonna see generally is I've already got some information or I've got a description of some information and I wanna translate that to a graph, okay? So what we need to be able to identify, if I've just got that description, is how I know what represents my X stuff and what represents my Y stuff. So what's my independent and what's my dependent variable. If we take a look at number 1, we'll work through this one, and I'll sort of guide you through this one, and we can talk about independent versus dependent. It says you want to figure out which brand of microwave popcorn pops the most kernels. You test different brands of popcorn to see which bag pops the most popcorn kernels. So remember, independent is the thing that I am in charge of, the thing that I decide or I choose. So the thing that I choose here is the brand of popcorn, right? I went to the store and I picked this box, this box, this box, and this one off the shelf, put it in my cart and bought them and came home, okay? That's the thing that I'm in charge of, is the brand of popcorn. When I get home, I throw a bag in the microwave, pop it, and then see how many kernels are left. Okay, so I picked the brand of popcorn. The thing that I'm then measuring is how many kernels are left, okay, or how many kernels popped, depending on how I'm going to run that experiment, okay, depending on the data I'm going to collect. So I'm not in charge of that. That's what I'm looking to see. That's what I'm collecting information on, is the number of kernels popped. That makes sense? Independent versus dependent, what I control versus what I'm measuring. Okay. Let's take a look at number 2 now. You're interested in how rising sea temperatures impact algae life. So you design an experiment that measures the number of algae in a sample of water taken from ocean sites with varying temperatures. Independent versus dependent variables. What's the thing that I'm controlling or I'm choosing? Yeah, I'm going around in my boat and sticking the thermometer in and seeing what temperature the water is and then taking a sample or not, right? The temperature of the water is the thing that I am being selective about, the thing that I am choosing. Then what's the dependent variable? What's the thing I'm measuring? What are we measuring here? That algae, right? I get back to my like lab, or maybe I've got a microscope on my boat, and I'm looking at how many algae are in this sample of water. Very good. Number 3, you're interested to see when you receive the greatest amount of notifications on your phone. You record how many notifications you receive every hour. What would be our independent variable here? Thing that I decide or I am in charge of. The time, yeah. When do I record these notifications? Is it every hour? Is it every 2 hours? Every 30 minutes? That's my independent variable. And then our dependent variable, what am I measuring or keeping track of? How many notifications I get. This is something that companies will do to decide when they should be posting things on social media. So they'll look at, if we create this post and put it up at 8 a.m., how much interaction do we get? Do we get a lot of likes or reposts at that time? Do we get a lot of comments if we post at this time? What if I post around lunchtime? Will I have a lot of interaction around lunchtime? People on their lunch break scrolling through like Twitter or Instagram or whatever, and are people seeing it then? Should I wait until like after work? that's what they're looking at, time versus the amount of interaction that they get on those different posts. And then finally on page 5, number 4, Metamora is conducting a study on home sale price value based on a home's square footage. Data on square footage and sale price is gathered from each real estate transaction in 2019. What's the thing that I am choosing or I am controlling here? I'm making choices based on what? Their square footage, right? I'm looking through all this information and picking out houses that have specific square footages. Then what would be the dependent variable? What's the other thing that we're looking at? Square footage versus price. Yeah, our price would be the dependent. Now, in some cases, this might be a little difficult to determine. This is the independent versus this is the dependent. So a couple of things I want to talk about before we move on from this page. In one of my earlier classes, somebody said they had a science teacher that told them for our class, time is always independent. Anybody else have that? Did a teacher tell you time is independent? Time's always going to be the independent variable? Okay. That for science and for that teacher's particular class is probably generally always going to be the case. For math, a lot of times that's the case too, especially if we're looking at taking a measurement of something at specific times. So I take a measurement of something every second or every minute or every hour. I'm taking some sort of measurement. I'm counting the notifications I get, or I don't know, looking at the height of something, okay, or the temperature of something. Time generally is going to be our independent variable. Maybe not always for math, but generally time is an independent variable. The other thing I want you to notice is that for some of these descriptions, we've got a kind of keyword in there. So if we take a look at number 2, it says you're interested in how rising sea temperatures impact algae life. Impact is one of those keywords that can give us a hint as to the independent versus the dependent variable, okay? So how does this impact this, okay? That means this is somehow getting a response out of this. So we said that dependent was our response, independent is our explanatory. So why are there more algae in this water than this water? This is the explanation, or that's our hypothesis at least. So impact is one of those keywords that can tell us this is the independent, this is the dependent. This impacts this means independent, dependent. Number 4 also has some of those keywords. In number 4, it says we're conducting a study based on home sale price value based on a home square footage. So I think that this is a result of this, okay? This is based on this, means this would be our independent and this would be our dependent. Same idea with my sort of key term there, just the order is flipped based on how it's phrased. So some things to look out for, especially if you're having a hard time with which one's independent, which one's dependent. See if you have some of those keywords in there. Questions for me so far? Okay. We're going to hop over page 6 for right now, and I want you to meet me on page 7. So on page 7, we're going to take those couple things we've talked about so far today and kind of put them together. So on page 7, this is during a snowstorm, Alex tracked the amount of snow on the ground. When the storm began, there were 3 inches of snow on the ground. So we already have 3 inches of snow from yesterday or last week or something. So at the beginning, we've got 3 inches of snow. And then for the first 3 hours of the storm, so hours 1, 2, and 3, for the first 3 hours of the storm, snow fell at a constant rate of 1 inch per hour. So 1 inch per hour. And what we're tracking here is the total amount of snow that we have. So we started with 3 inches. After the first hour of our storm, we add another inch to that total. And then in another hour, we add another inch. In another hour, we add another inch. So we're taking this description we have here and listing out the sort of collected values that Alex would have gotten. Then the storm stopped for 5 hours. So 1, 2, 3, 4, 5. In this chunk, our storm stopped. So what does that mean for the total amount of snow that we have? It's going to stay the same. Yeah, we're going to keep it 6 inches for a little while. We have no new snow falling right now. Okay. And then start it again at a constant rate for the next 6 hours. So 1, 2, 3, 4, 5, 6 for this 6-hour block. We're snowing again at that constant rate. It didn't give me a new constant rate, so I'm going to go back to that 1 inch per hour. So then we'll add another inch for each of the next few hours. Put this up here. Now, notice for the coordinate plane that we have, our axes are already labeled. We've got our x-axis and y-axis labeled with descriptions, and we also have labels for each sort of grid line, what each of them represent. Remember, when you have to create the labels yourselves, make sure that you are specific what we're measuring and how we're measuring it. We're measuring time in hours, we're measuring snow in inches, and then also make sure you're consistent with your values here. So I can't go from 0 to 100 to 150 to 152 to 153. I need to make sure that those gaps all represent the same amount. If for some reason they can't, then remember you can always do that little graph break, okay? That little sort of squiggle on the axis to represent we've got a jump here. Since we already have everything labeled, we can go ahead and plot our values here. So remember, time is on our x-axis, snow is on our y. So each of these is like an ordered pair. So 0, 3, we started with 3 inches, 1, 4, 2, 5, 3, 6, and then 4, 6, 5, 6, 6, 6, 7, 6, 8, 6. And it started snowing again. So I get 9, 7, 10, 8, 11, 9, 12, 10, 13, 11, and 14, 12. So there's all my information on my graph. Which of my variables is my independent variable here? What's the independent variable here? Time. And what's the dependent variable? Inches of snow, right? Now, the question I want to leave you with for today, and we'll answer this tomorrow. The question I want to leave you with for today. I have plotted the data from my table. Should I connect these points or not? Is this a scatter plot situation, or do I need some lines in here? Okay. So for this particular problem, I want you to think about what happens when it snows. Okay. So if it snows an inch per hour, does that mean 9 o'clock, inch of snow falls from the sky all at once? 10 o'clock, inch of snow falls from the sky all at once. Just a big like that comes down and lands on the ground. Is that normally how the snow works? No. Sometimes it's heavier and sometimes it's lighter over the course of an hour. But generally we get consistent precipitation. Okay? So I could have at some point 3.5 inches of snow. Would that be reasonable? Sure. 4.12 inches of snow at some point? Sure. Let's think about another example that you have probably seen at some point in a math problem. I'm going to buy t-shirts for a club. Math word problems, they love buying t-shirts for clubs. I don't know why, but they really like it. So can I buy 5 t-shirts for the members of my club? Is that a reasonable number of t-shirts to have to purchase potentially? Sure. How about 6 t-shirts? How about 5.5 t-shirts? Then probably not, right? So what we're going to talk about tomorrow is there are going to be times when we are going to treat our data as discrete little points. There can be nothing in between. And there'll be times when we'll say, hey, actually, these are measurements I took at unique times, but I would have gotten all of the values in between there as well. So that's where we're going to stop today. We're going to pick up tomorrow with this idea of, do I connect points or not? Do I throw arrows on the end or not? What makes sense?